Alright, let's look at the homework 5.5, 5.6, problem number 1. Alright, so we want to sketch the region bounded by these three curves. Alright, so let's do that. Alright, so first thing I would do is I'm gonna just rewrite it. This is kind of designed pretty nicely. This is just the x minus 5 quantity squared. Alright, so we can factor these guys out. So, and this guy right here is x minus 13 squared. Alright, so we know that this is just going to be a horizontal shifting on the parabola y equals x squared. Alright, so if you were to sketch the graph, you can see that this is going to be, alright, so original parabola go through the origin, but this is going to shift to the right 5 units. So we know that it's going to go through 5 right here. Then you would have a parabola. So it's going to look like this, more or less. Alright. And the second one is shifted to the right 13 units. So 13 would be, let's say, somewhere around here. Right? Then the parabola looks like this, goes through that point. Alright. Then y equals x, this is the same thing as the x-axis. Sorry, y equals 0. X-axis. So that'll be this guy right here. Alright, so we know that the region we are interested in would be that region right there. Alright, so let's go back and let's see which region. This is not it. And this looks promising, so here goes through 5 and 13, and that's the region. So this is the region that we are interested in. Alright, then we want to find the area. Alright, so let's do that. Alright, so we want to split this into two separate regions. Alright, so right here. And we can use symmetry, or we can look for the intersection. So maybe we should do that. We set these two parabolas equal to each other so we can find the intersection point. So we have x squared minus 10x plus 25. So that's the first parabola. And the second parabola is x squared minus 26x and plus 169. Right? Then first thing we do is, since we have x squared on both sides, so we subtract x squared from both sides, so we can cancel that out. And I would probably put all the terms with x on the left, everything else on the right. So I would add 26x so that we can move this guy over to this side, right? Which is going to give us, let's see, negative 10 plus 26, so it's a 16x. Alright, and then we want to move 25 over to the other side, so I would subtract 25. Right, so that way you would have, right, so 169 minus 25, so it's 144. Right, then all you have to do is divide through by 16 to isolate x. Alright, so 144 divided by 16, that'll be 9. Alright, so we know that here the intersection point, x coordinate is 9. Alright, so we have two regions. First one is, I'm going to call it the A1. and this guy is going to be A2. Alright, and you can see that during the symmetry, A1 and A2 is going to have the same area. So I'm going to go ahead and just find A1. So A1 is equal to, alright, so this is going to be an integral starting from 5 and ending at 9, right? Then the top curve is this first parabola, so I'm going to use this x minus 5 squared, right? Minus y equals 0, so minus 0 really doesn't do anything, so I'm going to just leave it as that. Then you have with respect to x. Alright, then if you want, you can actually make this pretty simple by using a substitution. So let say u be x minus 5. Then if you take the derivative of u with respect to x, you're going to get 1. Right, which means that we can just multiply by dx to show that du and dx are same, so they're interchangeable. Alright, then also x goes from 5 to 9, and which means that the u is going to go from, right, plugging 5 minus 5 is 0, and 9 minus 5 is 4, right? So this is going to be simply integral from 0 to 4, right? And remember that we decided to call this guy u, so that's our substitution. So we have u squared, and the dx is interchangeable with du, right? Then find the antiderivative, so this is just a power rule. U cubed over 3, and then you're going from 0 to 4, right? So we have 4 cubed, so 4 times 4 is 16, 16 times 4 is, let's see, 64, right? And divide by 3, right? Then minus, plug in 0, so we have that. So A1 is 64 over 3, and you will see that you can find A2 by integral from 9 to 13, and the top curve is the second parabola, so you have x minus 13 squared dx. But I'm going to cheat a little bit, so I know that this is going to give you the same area as before, so I'm going to just go ahead and do this. Alright, then since the area that we're looking for is the combination of A1 and A2, so we will have 64 over 3 times 2, so 128 over 3. Right, so let's type it in. Right, 180. Oh, actually, did I mess it up? 128. Okay, so 128 over 3 is the area. Right, so let's submit for testing. Right, submit for testing. Alright, it came back. Looks like we got the correct graph and we got the correct area. Alright, that's it. I hope that this was clear.